Welcome to Prince Maths Clinic, the e-learning solution at your pace and time. I welcome you once again to class, and today we shall be considering this very important aspect in mathematics, which is logarithm. As a way of introducing logarithm to you, let me first of all define or explain the word logarithm. In clear terms, logarithm can be defined, or a log of a number can be said to be the power, the exponent, or the index to which a base can be raised. I will take that in another way. Logarithm is simply the power to which a base can be raised in order to give you that log. Now, look at this example on the board. We have here that 2 to the power of 3, and we know that 2 to the power of 3 means 2 times 2, which is 4. 4 times 2 gives us 8. Therefore, to find the log of this 8, we have to use the base of what? 2 to give us this power of 3. Look at it here. 2 is a base here carrying the power of 3, and this 2 that's a base here is still a base here. The power to which this base is raised is the log of this number. So to convert it from log back to index, you can say 2, this base carrying this, is equal to this. If you want to write it in log form like this, you say the log of 8 in base 2 gives us this power of 3. The next aspect we shall be looking at are the laws of logarithm. The first law we shall be looking at is the law of addition. The addition law. And what does the addition law tell us? The addition law states that if I have a log in base b that has the multiple of x times y, this law says that log of x in base b should be added to the log of y in base b. As long as the bases are the same under addition, we are free to multiply these two logs together to give us this. And I want to prove this to you, to show you that this is actually correct. So let's go right into the proof of this law. The first thing we want to do is to assume that log x base b equals to something, right? So let log x to base b equals to p, and log y to base b, let it be equals to q. Is that interesting? Good. So I want to convert this from log to the index form. Remember, from log to the index form, you just say this base carrying this equal to this, right? As we have here. Therefore, doing the same thing to this become our x. Here will just become b to the power of p. And this as well, y, will become b to the power of q. Right? Hope you are following. Good. Then we can multiply x times y. Remember, the law wants us to multiply x and y. Good. So if I multiply x times y, what is x? X is b to the power of p. Then what is y? Y is what? B to the power of q. Remember, we are multiplying. Going by the laws of indices, we know that when the bases are the same under multiplication, you add the second power to the first power. Therefore, doing that, you have xy to be equals to b to the power of p plus q. Let me put this in a parenthesis. So this is the result from this, because the law says that once the bases are the same, you add up their powers. Now, moment of truth. How do we transform this into this? Remember, the base we are given in the log is base b. So I'm going to take the log of both sides in base b. If the base here given to us was 10, I would have taken the log of both sides in base 10. If the log is in base c, I will take the log of both sides in base c. Whatever base that has been given to us, take the log of both sides in that particular base. So in this case, the base is b. Therefore, now taking the log of both sides, this is what we have in base b. Then we have a law in logarithm that says that when a log is carrying a power like this, you have log b to base c. Take this power, multiply it with the log. So this becomes c log b base 10. So we are going to apply that law here. And in this case, the power is p plus q. So hence, log xy base b is equals to p plus q log b base b. Now, we know that from the laws of logarithm, when a log and the base are the same, it is simply equal to 1, which can easily be proven. Convert this back to indices. This becomes b raised to power 1, and b raised to power 1 is still equal to b. So you can see that when the log and the base are the same, it turns to 1. You can see that in the process of proving the laws of addition, the law of addition, I have branched into two other laws, which is the law of power and the law of a base that has the same value as the log. Now, since this log b base b gives us 1, everything here turns to 1. Therefore, log xy base b is equals to just p plus q. Now, we have to recall that we have called this x base b to be equal to p, right? Good. And we said that let log y base b equals to what? Q. So I'm going to substitute them back into this. Hence, log xy base b is equals to log x base b plus log y base b. So we have simply proved that using this method. Let's look at one question as it applies to this. Now we have to simplify log 5 base 10 plus log 2 base 10. Here's what we are going to do. Remember, when the bases are the same under addition, just multiply the log. Simple. The log here is 5 and 2. The bases are the same. Solution. Write out your question. You bring out one of the log, the bases, right? So 5 multiplied by 2. And what is 5 multiplied by 2? You get 10. Interestingly, in the process of proving this law, we saw that when a log and a base are the same, it becomes 1. So log 10 base 10 equal to 1. That is a simplification of this particular question. Let's look at the second law, which is the law of subtraction. The law of subtraction tells us that under division, and division could be in this form or it could be in this form, log x base b divided by log y base b. You see that in this form that we have a numerator and denominator, or we have the division sign here expressly written. When you have two logs that are being divided, you simply subtract the second log from the first as long as the bases are the same. Am I clear? Good. I'll take it again. Under division, as long as the base is the same, just subtract the log of y base b from the log of log x base b. Same way, if you have two logs being subtracted, one from the other, and you're asked to simplify, as long as the bases are the same, it becomes the log of that base. Just say x. The one that comes first stays at the numerator, the second one stays at the denominator. Good. Let's prove this law as well. In order to do this, we need to assign log x base b a particular letter and log y base b to a particular letter as well. So, assuming that log x base b, let us call this p, and log y base b, let's call it q. So converting again from logarithm to index form, like you have here, remember the base will carry this, becomes this. The base carrying this becomes this. So therefore we have it as 2 to the power of 3 equal to 8. Similarly, x here will become b to the power of p, and y will become b to the power of q. And since the law here is about division, you can now say x over y equal to, now what is x? X is simply b to the power of p. And what is y? Y is simply b to the power of q. Interesting. And we know from the laws of indices that once the bases are the same, you can subtract the power in the denominator from the power of the numerator. So this becomes b to the power of p minus q. So this becomes x over y equals to b to the power of p minus q. So the thing to do here now is to take the log of both sides. In this case, the base is b, right? So we are going to take the log of both sides in base b. Taking the log of both sides in base b, here is what we have. And we have already discussed this before, that when a log is carrying a power, the power multiplies the log. We discussed the other time that once you have a log, let's say log b carrying a power of c in base x, this power multiplies the log. This becomes c log b base x. So applying this particular principle, we will now say log base b x over y is equals to p minus q log b base b. And we have already explained that when a log and a base are the same, it turns to 1. Therefore, log x over y base b is p minus q. And remember, we said that let p be equals to log x base b and let q be equals to what? Log y base b. So I'm going to put those logs back here. Hence, log x over y base b is equals to log x base b minus log y base b as required from our proof. So let's look at applying this law in this example. Interesting, we are given that we should simplify this. And from the law we just examined, once the bases are the same, just divide. Right? Good. So this becomes log 10 base 2 minus log 5 base 2 becomes log in base 2. Then you have 10 divided by 5. In this case, the base is base 2. And 5 can go in 10 how many times? 2 times. So I have log 2 base 2. And log 2 base 2 gives me what? 1. At this point, I would like to invite you to subscribe to this channel if you have not done so. Because in this channel, we shall be considering a whole lot of solution to different aspects of mathematics, cutting across SSC questions, Olympiad Maths Challenge, IGCSE questions, SAT questions, and you can just go on and mention. So invite your friends to join you in this adventure. Till we meet again, bye for now.